Hi everyone, today we are looking at finding the area of shapes. And so when we found the area of shapes before, you have had something like a square or a rectangle, and we've looked at length times width. Well, today what we're going to do is we're going to be looking at changing length times width and turning it into equals the area. We're going to turn it into base times the height, and that's going to equal area from now on. So base, the base of a shape, so B, and they write it as a fancy B, is the base, and it's what the shape sits on. Okay, and then the height, well, the height is on a right angle. So H stands for the height, and it is like going up or how tall the shape is. So we can remember this by saying the height is on the right angle, because not all of our shapes are going to have a length and a width just right there that we can see right away. So it's going to be important for us to remember our new way of finding area for shapes. Okay, so let's go ahead and take a look at a parallelogram. Okay, so our first example, example A, I have a parallelogram. So with my parallelogram, you can see that the sides are slanted. Parallelograms do not go straight up and down. However, if I were to cut off this part right here and move it over to here, I would have a square or a rectangle. So we use this dotted line, or a line that goes from here and makes a right angle, as the height, because the line is slanted at an angle. So this is 14 meters, and the bottom is 12 meters. So when we're looking at this, we can see that we're going to use the formula base times height. So base times the height to find the area, and so our base is 12. It's on the bottom of the shape. If this is 12, this is also 12 up above. So our base is 12, and we're going to multiply that by the height that's on the right. So here's our height. It makes kind of like an H or a right angle. We're going to multiply that by 14. And that gives us a grand total of 168 meters squared. So our area is 168 meters squared on this parallelogram. Okay, so same thing as you would have done with a rectangle or a square, but because it doesn't have straight angles, we have to adjust for that by finding the right angle that would be the straight 90 degrees. Okay. Another parallelogram that we can look at is example B. And on example B, we have a parallelogram that runs like this. And this parallelogram, the area that we're looking at is all of this inside of here. Now again, because this doesn't have any sides that are straight 90 degrees like a square or a rectangle, we're going to use a right angle for the height. They will give you a right angle right here. Okay, that's because if we were to cut off this part here and slide it over to here, we would have a rectangle. So parallelograms are just slanted. So here it says that our height is 8.5 feet. And down on the bottom, it is 4 feet. I know that it's 4 feet because the top is the same length as the bottom, even though it doesn't look like it in the picture. It is, I promise. So Again, we're going to use that same formula of base times height equaling the area, and we're going to multiply. So the base is 4, and we're going to multiply that by the height, which is 8.5, and we're just going to solve. And so our area that we get is 34 feet squared. And again, we're squaring it because it's the area. All right, it is your turn now to do some triads. I want you to do some triads real quick before we head into triangles. So your first triad is going to be a parallelogram that is shifted this direction. And it has a right angle, or the right angle of 25 meters. And 20 meters on the bottom. And then triad number 2 of parallelograms. Again, we're going to have one line there, and like this. It tells us that the right angle is here, because if I were to cut this part off and slap it over here, my height would be right here, and it is 18 inches and 7 inches on the bottom. All right, so go ahead and do your triads right now. When you're ready, hit play so that you can see how to solve them. All right, the base is 20, so base times the height. My height here is 25. So 20 times 25, I know that 10 times 25 is 250. And 250 plus 250 is 500. So 500 meters squared is my area. On this problem, I have 7 inches, and I'm going to multiply that by 18. So 7 times 18. And 7 times 18, 56, 7, 12, 126. So I get a total of 126 inches squared. Okay, how did you do on your 2 triads there? How did you do? All right, now what we're going to look at is the area of a triangle. So the next shape that we're looking at is the area of a triangle. So as we're solving these problems, we're going to see that the area of triangles are kind of similar because they don't have those straight angles. And they're also different because they have half, right? So a triangle that we're looking at could look like this. Okay, again, we're going to use the base on the bottom of the triangle. And then we're going to use the height on the right angle. And in order to solve this, a triangle, we're going to find the area by taking half of the height times the base, or half the base times the height, okay? Or you can write it like this: area equals base times height divided by 2. Because a triangle is just a square cut in half. And I will show you that in just a second in example C. All right, so example C that we have right here, I have a right triangle. And on my right triangle, I have 8 inches here. And the base, I have 5 inches. So to solve for this problem, I am going to take my base, which is 5, and plug that in. And I'm going to multiply that by 8, because 8 is the height. And that gives me 40. But I'm not finding a whole entire square. So instead of finding a whole square, I'm only finding half of it. This half right here. Okay, so I have half of a square. Well, half a square, so I need to cut this in half, and that gives me 20 inches squared. because it's only half. So that's my total. So I'm still multiplying base times height, but then I have to chop it in half because a triangle is half of a square. I have two triangles to make one whole. Now, not all triangles are created equally. Okay, so some triangles look different. Sometimes our triangles end up looking very slanted, just like our parallelograms. And because of that, they have to adjust for that right angle by showing you that if we were to pull this triangle apart and put it together like a square or a rectangle, the right angle would be over here. So if I were to cut off part of this and shift it over here, this is where my right angle would be. They say that this part is 9 meters and that the base is still 12 meters. All right, so now what we're going to do, again, we're going to look at the base, which is 12, and we're going to multiply that by our height, which is 9. And 12 times 9 is going to give me 108. But I also need to divide that by 2 because it is a triangle. So as I divide that by 2, I'm going to get 54 meters squared because it's half. All right, it is your turn now to do your triads for the triangles. Oh, goodness, I just threw my green pen across the room. Great. Okay, so let's go ahead and do our triads. So triad number 1 on the triangles is a triangle that looks like this, and you have the right angle that looks like this, 10 meters and 22 meters here. And then triad number 2 is a triangle, and this one just happens to be upside down. So I have a triangle, and this triangle is floating upside down. So the base is here, and it gives me the height right here of 2 yards. Doesn't matter that this is upside down. You can actually flip it over and you would have a triangle on its base and you would be totally fine. So don't let that throw you off, okay? All right, so go ahead and hit pause right now so you don't hear me solving. And then when you're ready, you can go ahead and hit play. All right, my base is 22. So I'm going to multiply 22 times 10. That gives me 220. I need to chop that in half, and that gives me a total of 110 meters squared. And then on my second one, I have 2 yards times 6 yards. So I'm going to multiply 6 by 2, and that equals 12. I'm going to chop that in half, and that gives me 6 yards squared. That is my total. All right, go ahead now and answer your essential question. How do you solve for the area of shapes? If we were looking at the perimeter of these shapes, we would just add all the sides. They would give them to us, and we would just add them all up just like normal. Same thing with the perimeter of a parallelogram. If we were looking at the perimeter of a parallelogram, we would just walk around the shape and add it up. So that's how you find perimeter, and that's how you find the area. Put your level of understanding out to the side, and when you are finished, you can come on back to the Google Meet and ask for help, or you can do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.